In this video, we're going to talk about one of the key components of a line, which is the slope. So we're going to first define what that is, work through calculating it, and then we're going to use that to talk about when are lines parallel and perpendicular or neither. So first and foremost, the slope itself is really the ratio of the vertical change of a line to the horizontal change. So we can think of this just kind of pictorially as to what's going on. So here we've got a line. Here's some point on it, which we're going to call x1, y1. And then we have another point on the line. Maybe we pick the one down here, x2, y2. So we can really think of this in terms of a triangle. So I can drop a line straight down and then also to the left here. So between these 2 points, we're trying to figure out how much does it vertically change by and how much does it horizontally change by. So our vertical change is going to be the difference in those y values. So this is what we call our rise. Okay. In this specific example, it is falling, but that's okay. So the rise is going to be just the difference in y values. So this is sometimes denoted with this triangle and a y. It just means delta y. So that's always going to represent the change in the y values. And so what we do is we take the end value and subtract the initial value. So it's y2 minus y1. Now we also need what the horizontal change is between these 2 points. And this is what we classify as our run. Okay. So it is our change in x values. We take the end point and subtract the initial point. Okay. So we always want to stay consistent with the point we pick our end value to be and the point we pick our initial value to be. And then our slope itself is the ratio of these two. So we take the change in y and divide it in the change in x. The easiest way to remember this is we take the rise and divide it by the run. So either way, the main thing you want to notice is that the same point goes first in both of these equations. It makes no difference which point you put first as long as you're consistent. So I don't want to be putting the y value from one equation first, or 1 point first, and then the x value from the other point first in the bottom. You just want to stay consistent. So let's go ahead and practice. We're going to find the slope between the given points. And in our first example, we have 0, 3, and -2, +1. Typically what you end up doing is this point goes first because you consider it to be the end value. So our slope, we denote with the letter m. It is a fraction, and we're taking the difference of two things in the top and bottom. So we'll go ahead and we'll make this our y2, y1. So I put the y value up top, the x value in the bottom. And then we subtract our other point, y value up top, x value in the bottom. So in the numerator, we end up with 1 minus 3, which is -2. In the denominator, -2 minus 0 is -2. -2 over -2 turns into a +1. So our slope is 1. Or we can do this the other way. We still make a fraction and we want to look at our change in y values, but let's put the other point first. So we're going to start with 0, 3. Y in the top, x in the bottom, and then our second point is here, y in the top, x in the bottom. So we have -2 down there. 3 minus 2 gives us a +2. 0 minus -2 is really 0 plus 2. So we end up with +2 over +2, which is a 1. So each instance, it makes no difference which point went first. We found out our slope is 1. So let's try with another example. We're going to find the slope between 0, -4, and 1, -4. So So we set up our fraction, and we're going to be doing subtraction. We'll go ahead and put the second point first. So -4 is the y value, 1 is the x. And then we'll put this point second. -4 is the y value, 0 is the x. This really gives us -4 plus 4 in the numerator. 1 minus 0 in the bottom is 1. But if we add those two in the numerator, we really get 0 divided by -1, which gives us a slope of 0. So if you think of that, a slope of 0 means there's no rise at all. So ultimately, if you were to graph these 2 points, the y value is -4. So we plot the point 0, -4, and then 1, -4. It's just a horizontal line. So no change at all. So again, biggest thing to take away, it makes no difference which point you pick to be first, as long as you are consistent. So now the slope of the line gives us a little bit of information about what the graph looks like. If we have a positive slope, that means it's going to be rising as you read the graph from left to right, same as you read a sentence. A negative slope means the line is going to slant down and it's actually falling. A slope of 0 is going to be a horizontal line, just like that last example. And then finally, if you have an undefined slope, which basically means you're going to try to divide by 0, which you can't do, that's going to be when we have a vertical line. So basically the rise is infinite. So to give you just a picture example of each of these, we'll do 4 little pictures. And we'll go ahead and cheat because we're using an iPad and do 4 different graphs. So in the case that we have a positive slope, so it's a positive number, our graph is rising as we go upward. A negative slope means our graph is falling from left to right, so it looks something like this. Again, could be a different steepness though. A slope of 0 indicates we have a flat line, and an undefined slope is going to be a vertical line. The undefined slope is honestly the hardest one when we deal with equations or building the equation of a line. That one's always going to take a little extra, just kind of, hey, this is something weird going on and I need to recognize this is the case. For these other 3 instances, when we build a line, you're following exactly the same process, but vertical lines are a little weird. So we'll get plenty more practice in the other videos finding slopes, and here we're still going to work with finding slopes some more, but we want to talk about lines in conjunction with each other. So if I have 2 lines, can we figure out maybe some properties involving both of them? So we're going to take a look at the slope in all of these instances. If 2 lines end up having the same slope, they're going to run together and run parallel to each other. They'll never intersect. If 2 lines are perpendicular, they're going to form a 90-degree angle. And in this case, their slopes are known as negative reciprocals of each other. So this is a little bit harder. Parallel's much nicer. To give you some examples of what negative reciprocals mean, if you have 2/3, its reciprocal is the flip. So the numerator and denominator switch positions. So it's 3/2. Negative reciprocal just means they're opposite signs of each other. So one is positive, one is negative. In the case that you have a whole number like 5, its reciprocal is 1/5. 2's reciprocal is 1/2. So again, to be negative reciprocals, you have that minus sign, and then you flip the fraction. Horizontal and vertical lines are the only ones we really can't compare the slopes for. But if you think of that just based on our axes, the x-axis and y-axis are horizontal and vertical lines. They form a 90-degree angle. So we have these three instances where the lines can be parallel. So they just run next to each other forever. They will never intersect. And so because of that, they have exactly the same rise over run. In the case that they are perpendicular, one line can maybe be here. The line that's perpendicular will form a 90-degree angle, as best as we can possibly draw. So this angle here would be 90 degrees. And then the last case is there might be no connection between these two lines at all. And this is our case of neither. So maybe I have a line here and the other line intersects like this. Okay. So they intersect each other, but they don't intersect at a 90-degree angle. There's no relationship between the slopes. So we're going to go through two examples, and for both of them we're going to determine whether the pair of lines are parallel, perpendicular, or neither. And so in our first example, we're told the first line passes through the point 15, 9 and 12, negative 7. The second line passes through 5, negative 20. So the only thing we need for these is what is the slope of each line. Then I'm going to make a comparison between the two. So we'll start with the slope of line 1. And so I'm going to call it M1, just so I know this is line 1. We need a fraction again, and we're going to subtract some things. So let's pick this to be our first point. So our y value is 9, our x value is 15, and we want to subtract the other point. So our y value is negative 7, the x value is 12. So we have the difference in y values over difference in x values. So this leaves us with 9 plus 7 in the numerator, and then 15 minus 12 is 3 in the denominator. So if we add that top, the slope is unfortunately not a nice number. It is 16 over 3. So we've got the slope of our first line. We need to compare it to what the slope of the second line is. So we'll call this one M2. And again, make a nice fraction. We want to look at the difference in the y values. So we'll pick this point to be our first one. We've got negative 20 and 5 as our point. And then we'll do 8, 4 as our end point. So we want negative 4 in the numerator, 8 in the bottom. So difference in y values over difference in x values. And so this leaves us with negative 20 plus 4 in the numerator, and then 5 minus 8 is negative 3. So we get negative 16 in the numerator after subtracting, negative 3 in the denominator, which really those minus signs cancel each other out, and we end up with 16 over 3. So the slope of line 1 is 16 over 3. Slope of line 2 is also 16 over 3. So since the slopes are equal, these lines are parallel. So there is that connection between the two. Example, we're given the equation of line 1, and then we're just told line 2 has a slope of 4. So again, I need to compare slopes. This one we already know, But in the first one, we've got to figure out what the slope is. So we need to find the slope of line 1. Unfortunately, though, I need 2 points to find the slope. So what I need to do is we need to find 2 points on the line. Then we can figure out what the slope is going to be. So in both of these cases, let's just find the intercepts. So 1 point is going to be the x-intercept. So we'll set y equal to 0. And that gives us x plus 4 times 0 is 8. So ultimately, x plus 0 gives us x equals 8. So 1 point on our line is 8, 0. If we find the y-intercept, we go ahead and set x equal to 0. And that gives us 0 plus 4y is 8. So 4y equals 8. And dividing by 4 gives us y is equal to 2. So another point on our line is 0, 2. Okay. So now we can find the slope of line 1. Which again, we'll call M1. We go ahead and look at the difference in y values. So that's 2 minus 0, going through those. And then we do the difference in x values, which is 0 minus 8. So that leaves us with 2 in the numerator, negative 8 in the denominator. But I need to compare this slope to the one of line 2, so I want to simplify this as much as I possibly can. Both the numerator and denominator are divisible by 2. So that leaves us with 1 over negative 4, or negative 1/4. So the slope of line 1 is negative 1/4. The slope of line 2 is 4. They're definitely opposite signs, and they are negative reciprocals. So if you're unsure of that, the negative reciprocal of line 1, negative reciprocal of this, is going to be flip the fraction and change the sign. So it becomes positive 4 over 1, or 4. So line 1 and line 2 have slopes that are negative reciprocals. These lines are perpendicular. So make sure you get lots and lots and lots of practice going through these slopes. Be very careful about how you actually calculate. Take your time, add more steps than you need. Because the worst thing you can do is just make a sign error and then have to figure out where you went wrong. Really, you just need to start the problem over and try it again.